Bismillahirrahmanirrahim. In this lesson, we are going to discuss significant figures. This is not important as a part of mathematics O level, but in A level as well as in science subjects, everywhere we require the concepts of significant figures. Here we will discuss the basic few things about significant figures, but we won't discuss the requirement in science subjects like in chemistry or physics, but we will restrict ourselves to the basic concepts of significant figures in mathematics, especially O level, and it will be slightly extended but not in more detail. So let's see. Significant figures, that is the figures in a number, we consider them significant. Like if there are all non-zero digits in a number, then the number of digits, that is significant. So all non-zero numbers. Non-zero numbers means such numbers in which there is no zero. Then all non-zero numbers are significant. Like if the number is 526, or you can say 57258, or 57.39, or any other number. If all the non-zero digits are there, then this number, this one, this is three significant figures, 1, 2, 3. In this number, 1, 2, 3, 4, 5 digits are there, and there is no decimal, no non-zero, no zero in this. All the non-zero digits are there. So this is 5 significant figures. In this one, 1, 2, 3, 4, there are 4 non-zero digits. We won't consider this decimal while deciding about its significance. So these are 4 significant figures. So that means there is no difference between numbers with decimal or without decimal if we are counting the number of significant figures. It's very simple, that number of digits, you count them, and that is the number of significant figures. Okay, now next, zeros between non-zero digits are significant. Zeros between non-zero digits. How is it? That is almost similar to this concept. We won't differentiate between zeros or non-zero digits while counting the number of significant figures. Like this was 526, if it is 506, or 50008. These are two non-zero digits, and zeros are between non-zero digits. Or if it is 60.07, then these are non-zero digits and zeros are in between them. So once again, it makes no difference whether there is a decimal or not. So this one we simply straight away we count the number of digits. This is 3 significant figures. In this one, 1, 2, 3, 4, 5. This is 5 significant figure. And this one, since the zeros are between non-zero digits, therefore these zeros will also be counted. 1, 2, 3, 4. This is 4 significant figures. Okay, now actually the main thing to understand in significant figures is that if the zeros are there in the beginning or at the end of a number. So if zeros are in the beginning, look, once again keep in mind that these zeros are not in the beginning or at the end. So we are talking about such zeros which are before any non-zero digit and or after a non-zero digit. So zeros before a non-zero digit are called leading zeros, and zeros after non-zero digit at the end on the right hand side, they are called trailing zeros. So if I make a table, a small table, I think it would be better to compare these things, that here, because leading zeros and trailing zeros are to be considered with both, with the numbers, with whole numbers as well as decimal numbers. So we can compare easily if I make this table. So this column is for leading zeros, and this is for trailing zeros, and I make 2 rows, one row for leading and trailing zeros for decimal numbers, and the other one leading and trailing zeros for whole numbers. So this is here, this row is for decimals and this is for whole numbers. Now leading zeros in decimals are like 0.0056 or 0.05 or any number like 0.00072. Now in all of these zeros, and one thing you have to be clear about, that when we talk about these zeros, so you should be able to notice that in the beginning there is 0, here it is 0, here it is 0. So these are leading zeros because there is no non-zero value before that. In a case like this is not leading zero because that is between two non-zero digits. So we have separately discussed about zeros between two non-zero digits. If in the beginning and at the end, if there are non-zero digits, then these zeros are in between. And we have already defined the rule for that, that all such zeros will be significant. Now, a specific thing about these zeros is that in the beginning there is no non-zero digits, so these are called leading zeros. So these zeros these three zeros or these two zeros or this zero. So leading zeros are not significant. Leading zeros are not significant. This color is very light. Okay. Leading zeros are not significant. Not significant. So okay, now let's compare leading zeros in the whole numbers. Leading zeros in whole numbers. Like sometimes we write the numbers this way, 0, 0, 2. If we make a list like 0, 0, 2, 3, 4 this way, and then 0, 0, 8, 0, 0, 9, and then 0, 1, 0, 0, 1, 1, 0, 1, 2. If we are expecting the list up to 1000, then from the beginning 999 you can say. From the beginning we write the numbers in 3 digits, but initially the 2 digits are 0, then 1 digit is here, then on the way if we continue then there will be a number 201 and so on, 998 or 999. So in the beginning we can write leading zeros. So such zeros which have no significance, they are known as placeholders. These two zeros or these zeros, they are called placeholders. I think I should write it here that they are placeholders which are not significant. So first let me shift this word from here. Such zeros are just placeholders. What do we mean by placeholders? That they just tell us that this is 1/10 of the number, 1/100th, 1,000th, and this 7 is now 1 over 10,000, 7 over 10,000, and this is 2 over 100,000. This 5 its place is decided by this zero. So these zeros are placeholders. They are not significant. So what is the number of significant figures in this one? This is two significant figures, this and this. This is one significant figure. Because this is only one non-zero digit, this is placeholder, so that does not contribute in significant figures. In this case, this is two significant figures. So these zero do not decide about the significance of the number. They are such just placeholders. Okay. Now, in case of whole numbers, leading zeros in whole numbers. Once again, this is one significant figure, 024 or 076. This is two significant figures. This is again two significant figures, and same like decimals, these zeros, these two zeros, or this zero or this zero. Zeros are not significant. Zeros are not significant. That means matter of zeros regarding leading zeros regarding decimal and whole number, they are same. It does not make a difference whether it is a number with or without decimal. So I write it here. This is two significant figures. Okay, let me extend this line. Okay, this is the method of leading zeros regarding decimals and whole numbers. I think it is clear now. Okay, now we move to the trailing zeros. Trailing zeros are zeros on the right hand side, like 5.0 or 3.50 or 2.00, or you can say that 7.000. If we write this way, then all these are trailing zeros. These two are here. This is one trailing zero, two trailing zeros, and three trailing zeros. So in this case, if there are trailing zeros, these three are three trailing zeros. This is one trailing zero. This is one trailing zero. And what is the number of significant figures? So trailing zeros are significant. Trailing zeros are significant. trailing zeros are significant. There is no doubt in it, and there is no debate about it. Whenever there are zeros after decimal without any non-zero digit at the end, then these zeros are significant. So this number is now two significant figures, because one significant figure 5 itself and the other significant figure is 0. So two significant figures. This number, this is three significant figures. This one, again, this is three significant figures. And this number, this is four significant figures. So all the zeros are significant. And in case of whole numbers, this is 2000 or 500 or 10,000 like this, or any other figure. So all these are trailing zeros. In case of whole numbers, these are trailing zeros. These two are trailing zeros. There are 5 trailing zeros, 3 trailing zeros. I just write T and Z. These are 2 trailing zeros. Here are 4 trailing zeros, and these are 5 trailing zeros. So in case of whole numbers, trailing zeros are not significant. Trailing zeros are not significant. Okay. Now, one or two more things we will discuss. That let's say if there is a number 200 and if there is decimal at the end, now zeros are significant now. That means this is now 4 significant figures. If it is written 2000 and there is no decimal at the end, then this is one significant figure, because trailing zeros are not significant. Okay. Now one thing that is slightly confusing, and it should be clear, that if this is the number 0.3 and you are asked to write the number correct to 4 significant figures, what you can do? 2000 and decimal at the end. But if you are asked to write correct to 3 significant figures, you have no choice other than writing it this way. If you are asked to write it correct to 3 significant figures, once again, you have no other choice. So if you are asked to write it correct to 1 significant figure, then again you have to write this way. So if there are trailing zeros, then this is little ambiguous. This is not very clear statement. So if it is given like this, how many total number digits are there? 1, 2, 3, 4, 5, 6. Now, what is it? According to that definition, trailing zeros are not significant. So this is actually one significant figure. But if we have to round it off to two significant figures, so it can also be considered equal to two significant figures, or three significant figure, or four significant figure, or five significant figures, and six significant figures. So it depends that how many the significant figures you want to consider. Actually, minimum number of significant figures in it, and that is 6. But it can also be considered as 2, 3, 4, 5, or 6 significant figures. If that significance is required, as I said here, that this number, if you want to write it 4 significant figure, this is the answer. If you want to write it 3 significant figure, what else you can write? There is only this option, what you can do. If you are asked to write it correct to 2 significant figures, once again it will be there, the same number, and 1 significant figure, it is 1 significant figure, like this. Okay, now here, in all this detail, you can see that there are two types of numbers, decimals and whole numbers. There is no difference between them regarding leading zeros. In both of these types of numbers, leading zeros are not significant. And trailing zeros, in case of decimal, trailing zeros are significant. And trailing zeros in whole numbers are not actually significant, but in such cases you can consider them to be significant. Okay, now how the numbers like these numbers, why these trailing zeros are significant? I will try to explain here. Like let's say there is a measurement of 5 meter. We can write this 5 meter in different ways. Like number one, we can write it 5 meter, you can say. Or secondly, we can write it as 5.0 meter. Thirdly, if we write it as 5.00 meter, and then if we write it as 5.000 meter, this is number one, or you can say that this is one significant figure, this is two significant figures, this is three significant figures, and this is four significant figures. What difference does it make if we write in these different ways? Actually, this value 5 meters, it tells us that what is the precision of that number, that what number is expected to be rounded off to 5. So that may be for 4.5 to 5.5, that is greater than 4.5 and less than 5.5. That number you can say it is rounded off to 5. So if this is one significant figure, then 4.5 to 5.5 meters are rounded off to this number. Okay. Now if it is 5.0 meter, now its precision is correct to 1 decimal place. So if we consider meters into centimeters, there are 100 centimeters. So this is correct to 10 centimeters. 1/10 of meter is 10 centimeter. So now you can say that the value is between 495 centimeter, or in terms of meters you can say this is 4.95 meters and 5.05 meter. 5 centimeters less and 5 centimeters more than that. So 10 centimeters, rounded off correct to 10 centimeters. Okay, if it is 5.00, three significant figures, same value 5 meters is written as 5.00. Now its precision is correct to 1 centimeter. Because there are two decimal places, that means 1/100th of a centimeter of meter. Okay, better to change it to centimeters. So this is 500 centimeter correct to 1 centimeter, that is 499.5 and 501 centimeters, sorry, 500.5 centimeter, 500.5 centimeter. You can see that how close these values are with each other when this is correct to two zeros, two trailing zeros. So this is what you can notice, that if it is 5 meters, this is rounded off correct to 1 meter. Its rounding off is very rough, half meter this way or that. If it is 5.0, now it is rounded off to 10 centimeter, 5 centimeter this way or that way. And if it is 5.00, correct to three significant figures, then it is rounded off half centimeter this way or that. And if it is 5.000 meter, that means this is equal to 5000 millimeter. So now this is rounded off correct to 1 millimeter. So its precision among all these is the best one. The best precision we can expect in this one. So that is the difference this zero makes. If there is 1 0, its precision is correct to 10%. If it is 2 zeros, 1/100 of the precision. If it is 3 zeros, then its precision is 1/1000 of the value. So these trailing zeros in case of decimal, actually they change the precision. That is the reason these are very important to consider, that why do we put these zeros after decimal. Whereas these zeros in whole numbers, these zeros do not change their values. So these are not significant. That is the reason. Okay, now standard form. If a number is written in standard form, standard form is always written like 7.0 into 10 to the power 6 or 5.02 into 10 to the power 4, or this way many numbers are 6.67 into 10 to the power minus 11, or you can say 6.0 into 10 to the power 24. Any number like this, all these numbers, only these numbers are significant. This is two significant figures and the remaining are zeros. This is three significant figures and these are zeros. These zeros are not significant. These zeros are not significant. This is two significant figure. Once again, this is up to you whether you want to give the precision correct to two significant figures. You will write this way, otherwise it will be 6 into 10 to the power 24 and many more things. So only the numbers along with 10 power of 10, that is, this is one significant figure. If you write it 6.0, then it will be two significant figures. So that's it about significant figures. I hope that it would have become clear that what the significant figures are. So now you can apply these significant figures in different applications of physics or chemistry or mathematics, wherever, and I will try to do more topical questions about it from the past papers. Okay, Allah Hafiz.